In this problem, here it is given that k is a natural number such that it lies between 100 and 300. How many values of k exist such that factorial k has x zeros and factorial k plus 1 has x plus 3 zeros at the end? So first of all, understand the concept of 0. 0 basically means 10, which is 2 into 5. So 0 in a factorial is determined by the availability of 2 and 5, and in case of factorial, usually or all the time the number of 5 is lesser than the number of 2's, so we need to look after 5 in order to find the number of zeros in some factorial. It is given that if factorial k has x zeros, factorial k plus 1 has x plus 3 zeros, which means in factorial k there are x power of 5, which means factorial k is of the form 5 or is a multiple of 5 raised to power x, and factorial k plus 1 which has 3 more zeros than k factorial, which means it has to be a multiple of 5 raised to power x plus 3. So the additional quantity that we have here is 5 raised to power 3, which is 125, which means if and we also know that factorial k is equal to 1 plus 1 into 2 into 3 into 4 into up to k, and if it is talking about k plus 1, then it will become 1 into 2 into 3 and so on, k into k plus 1. This part of factorial k and factorial k plus 1 will contribute for x zeros, so the additional 3 zeros in k plus 1 factorial is contributed by k plus 1, and we know that for 3 additional zeros we need 3 additional 5, which means we need 5 raised to power 3. So from here it can be deduced that k plus 1 has to be a multiple of 125, and in that case k can be 124. In that case k plus 1 will be 125. In second case, when k plus 1 is next multiple of 125, which is 250, in that case k will be 249, and the next value of k plus 1 will be 375. In that case k will be 374, which is not possible as k lies between 100 and 300. Therefore the possible values of k are 124 and 249. Correspondingly, values of k plus 1 are 125 and 250. Therefore there are two values that k can have. Therefore option B is the correct answer.